Okay, the final exam, 25 questions. Uh, the first, as I said, first part is practical, and then the rest of it is the 23 questions are written questions, multiple choices. Okay, guys. So, and let's review whatever it's coming here. So we have, as you see in the exam, that's my very old final exam review I did a couple of years. So concentrate yourself on this topic because this one will be part of the practical. So density is mass over the volume. You will be given an unknown object, correct? You don't know what this object is, and you don't know its density. So then you will measure the volume of this unknown, I mean the mass and the volume, and determine the density, correct? So mass over the volume is the density. Then you will have A, B, C, D, multiple choices, and then you have to pick up the correct answer from those all choices. Correct, guys? So that's the first one. So let's look at here one of the examples here. If we have the mass, you will be weighing, correct? Say 2.55 grams, and you have to watch for the sig fix. It's very important, significant first. It's very important. And you put this one here. You did the displacement method, and that's the easiest one to do. So you did what? Displacement method. So what is displacement method is you take this is the you weigh this object, correct? And then you will take this graduate cylinder, you fill it up to, suppose this object is coming like this tall, okay? Then you will add H2O above the tall from outside. So this one here, this is tabor. And suppose it's now 10.5 ml, 2 digits after the decimal. Correct, guys? So then you'll take this metal here, you insert this metal inside, right? When you have to tilt this one here, tilting, and then you insert this metal here object inside, correct? And then back straighten up the whole thing and see where the metal is now at the bottom, and it's not 10, is now it's reading 15.50 ml. So it started with 10 and you end up with 15.5 ml. What is the density? The question is, what is the density? Okay, guys, so here it is. What is the density? Well, it turns out the density is mass over the volume. Density is mass over the volume. Mass is 255 gram. The volume here of the metal is the displaced H tabor, displaced tabor. So will be 15.50 minus 10.50. This is ml or centimeter cube, the same thing. So 1 ml is 1 centimeter cube, same units. So this one will be 2.55 grams divided by 5.00, this is 5 here, 00 ml, correct? So then you will have, this is 5, 1, so this one will be, this is 3 sig fix, 3 sig fix, The answer is 5, 1. That's your answer from the calculator. However, you have 3 sig fix, you'll have to add a 0 here, gram per mil, or 51.0 gram per centimeter cube, because ml centimeter cube are identical. So you have 3 sig fix here. Okay, guys, that's part of your practical question, how to do it. So you know that we are prepared to do the density, and we cover the density here together. Any question? Any question? Any question you have? No question? So if there's no question, then I assume everything is good. We'll make some sig fix problems. So can I take this one out? Can I take this one out? Okay. Take it out. Okay. So take this one out, and then we'll have about sig fix. Well, sometimes sig fix will give you the multiplication or division or addition and subtraction. Those two rules, division and multiplication, are identical rules, and the addition and subtraction are identical rules. So we'll give you somehow addition, for example, or multiplication. Say you have to solve 12.1 2.0 divided by 6.4 multiplied by 3.6. Okay, guys, so we have to make sure that, suppose this is 2, 2, this is 3, 1, this is 6, 1. So you do the whole calculation with the calculator, you get the answer here. But the most important thing is to round this one here to correct sig fix, correct? So in order to do this, I have to do all this, the least sig fix. So this one here is how many? 4, correct? This one how many? 3. This one how many? 4. This one how many? 4. So your answer has to have how many? 3 sig fix. Correct, guys? You can do the calculation yourself, but I'm setting the whole thing out to give you problems. But you have to do all this calculation with the calculator. But however, then when it comes to rounding off to the correct answer, then you have to be careful. Then you have to add, you have to look at the sig fix and the least sig fix, because this multiplication and division will be controlling the outcome of rounding off. Okay, guys? Any question? Any question? Okay, good. This is one. Same thing with addition and subtraction. Sometimes they will give you the setup of values and tell you what the sig fix. For example, 3.10, 2.551, 10 minus 3, 2.01, ln 2, 43, 10 minus 6, 8.00 log 0 log of 2, and so on. So sort of, they want you to determine. Then you have 1, 10, then 10 and decimal. Okay, you have 1,000, 1 and 1,000. So now let's solve this. The number of sig fix will be asked. Now, not the application, but number of sig fix. So the first one, how many? How many the first one? Come on, guys. When I make it interactive, how much is this one sig fix? Still remember? How much? Somebody is very shy. Very quiet. 3. Say 3. Yes. It's Monday. I know. I understand. I understand. It's 3. How about the second one? How much? Second one? That's interactive. I want you to be with me. So how much? How much? I can't hear. 4. Yeah. I want to hear something at least. How about the third one? So this one. How about this one here? Third one. How, how many? 3. Perfect. How about this one here? 2. Now we are talking. How about here? How many? 4. Not 1. 1 or 4? 1 or 4? Which one? Which one? Which one, guys? Come on. No? Are they significant, all of them, or not? What's keep them significant? If that's 4. If they are not significant, then it's 1. So if you feel that they are significant, what conditions are making them significant? Somebody will tell me? Yes, they come after whole number, and that's first condition. First. Second, the presence of what? Decimal. So this is 4. 2 conditions are met. Those zeros are coming after whole number, and then the presence of what? Of the decimal. Okay, guys. If I have them like this one how much? This one is 1. Perfect. Because it's what? Missing what? Missing the second condition, which is missing decimal. Missing the decimal, correct? So, how about this one here? How many? 1, not 2? 1 or 2? 1, perfect. How about this one here? 2. Why? Because it's meeting the 2 conditions. Whole number before them and the decimal. Correct? How about here? How many? 5 or 4? 5? 5. How about here? 1. Perfect. So now we are talking. Now we are talking. Good. Thank you. So that's good. That's very good. So, can I take this one out? Everybody has it? Everybody has it? Okay. That's good. Now, sometimes they will ask you about smallest value or the largest value. So which one is the smallest value of this one here? Which one is the smallest? Which one is the largest? Which one is the smallest? Which one is the largest? Come on, guys. Which one is the smallest? Which one is the largest? The smallest is what? The last one is the smallest? The first one? Somebody? Somebody has another opinion? Another answer? So, -8 is greater than -7, -3, or smaller than that. So, this is the smallest. Which one is the largest? The last one. So simple sometimes. You have to pay attention. You have to pay attention what to the plus minus and the value itself. So two items you have to watch. Okay, guys. So that's perfect. Now from this we will go for whisper. Correct? Are we ready for whisper? Are we ready for whisper? Let's take this one out and let's do whisper. Okay, for whisper here, I'll give you a compound looking like this. Then we can ask questions about this. Correct? So, what shape do we have here? What shape we have here? Then you have to memorize this small tiny chart I gave you by saying this is central atom, correct? This is B or X, whatever, X, or B some textbook. So this is AX2. AX2, no lone pair. This is what? Linear, correct? Correct? And with this in mind, linear is always 180 degrees. So the angle here between oxygen, carbon, and sulfur is 180. 180. What else we have to know further? Yes, further we can see if it's polar or non-polar. Polar or non-polar? Polar or non-polar? Why? You get the correct answer, but why? Because you have a different what? Different terminal atoms with different electronegativity, correct? So this is polar. But if I have something like this, look guys, something like this, or something like this, those are non-polar, correct? Those are non-polar. Can you see that? Because you have identical terminals. Both sides are identical. So the dipole will cancel themselves out. So this is non-polar. This is polar. Okay, guys? So let's take another one. Everybody has this? Everybody has this? Okay, so let's get another one. It's too big. Ph.D. Ph.D. It's polar, non-polar. It is shape. What type of shape? Pent, triangular, whatever. I mean, what's the shape? Tetrahedral. So we have to do what? Lewis dot structure. So the Lewis dot structure here is phosphorus has 5 what? Phosphorus has 5. Group 5 has 5 valence electrons. So this is one. This is one with hydrogen. This is one. This is one hydrogen. This is one. This is one hydrogen. So you have 1, 2, 3, and there's 2 left here. So this one here will be A, X, 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 and E here. A, X3, E1. This one is what, guys? What's that? Trigonal what? Something? No. Trigonal, that's a good start. trigonal pyramidal. Trigonal pyramidal. Okay? If I have one lone pair and three terminals and central atom AX3E1, that will be trigonal pyramidal. That's in the chart. Just look at the chart. Look at the chart. So now, how about another one? Let's take another one. Everybody has this? Everybody has this? Okay, let's take another one. H2S. Somebody remembers about this gas here? What's that? What is that gas? Fortin gas. Correct. Correct. That's coming out of the skunk stuff. Are you following me? Skunk. If you hit by skunk and defending itself, the skunk is producing a lot of mercaptan and H2S. It smells very bad, and your clothing will be for a couple of days, maybe weeks, smelling very bad. That's a Fortin gas. Okay, it smells very, very bad. So it's called dihydrogen sulfide, correct? Dihydrogen sulfide is an acid, weak acid. So what is the shape of it? Now I'll give you 1 minute and then to think about. I need to get this shape, molecular shape, not electronic, but molecular. So don't look it up. I want you to, what's the best way to achieve this one here, to answer this question? What's the shape of this? We have to do what first? How in the world I will know what shape is that without Lewis dot structure? So out of this, I have to draw Lewis dot structure. Without Lewis dot structure, I'll be not able to determine the shape, because the rules of the whisper will depend on what? On Lewis dot structure. The whole whisper is really rely and depend on Lewis dot structure. So hydrogen always at terminal. So hydrogen always here, terminal. Sulfur in the middle, and this one always hydrogen, we said in terminal. Sulfur has what? Has six groups, 6 valence electrons. 1 and 1 makes single here, because hydrogen cannot make double bond, always single. And 2 here, and 2 here. So this is A X X E E will be A X2 E 2. So 2 X's, 2 terminals, and 2 lone pairs. What the molecular shape of this? What's that? Did you look it up? No, really? Oh, that's good. That's excellent. Excellent. I'm just checking. So, everybody knows how to do it, correct? Okay, so anytime we have whisper, we have to look at the what? At the Lewis dot structure. Now, tell me if it's polar or non-polar. Polar or non-polar? What's that? Non-polar? Non-polar, everyone? Non-polar? Non-polar? Any other opinion? No? I said non-polar. Well, this is polar. Why? Why it's polar? You forgot about the rule. It has, anytime a central atom has lone pair, blindly without even looking at any rule. Central atom has lone pair, this molecule has to be polar. That's it. That's the rule. Anytime central atom does have a lone pair, I know you came out from the idea that's identical terminals, but the central atom does have lone pairs, so it has to be polar. And it is bent, and the angle is around maybe 105 or something degrees. Okay, guys, around that. So I think we covered this one. Okay, guys. Now, um, but we'll count the valence electrons, correct? I'll give you a molecule and tell me what's the valence electron of this molecule or compound. Any question so far? Any question? So let's take one out and let's look at the. And you gave me the you will give me the total valence electrons. Okay, so C6H12O6. I need to get the total VEs, valence electrons. So somebody has them? Somebody has them? Somebody calculate them? I know it's Monday, it's hard, I know, and after long holidays, I understand. So what's the total VEs of this? What's the total? Okay, guys. What's the total VEs of this? You'll be surprised that some of those will come up here, then you'll be shaking your head. Oh, I heard that somewhere. Okay, guys. Okay, so how I can approach this? Somebody will tell me? I have to look each element where is the group of this element. This is group number 4. So the valence electron of carbon is 4. Hydrogen is 1, group number 1. Oxygen, group number 6, valence electron 6. So then I have 6 of valence electron 4, 6 carbons, plus 1 or 12 multiplied by 1, okay, plus 6 multiplied by 6. Okay, guys, so this is 24 plus 12 plus 36. Okay, guys, so this is 6 and 6 is 2, 1, 4, 5, and 7. 72 VEs. Everybody agrees? Everybody agrees? Yes, so that's the way we can. The main thing for valence electron counting is to look at each element group. Which group is this element in? That will be the valence. Valence electrons number is equaling the number of the group. Number of group 4. So this is the valence electrons of this element 4 because it's found in group 4, correct? And so on. Group number 6, like oxygen and sulfur, so valence electron 6. So I think we covered that. Okay. Can I take this one out? Now let's tell me about balancing chemical equation with the coefficient, correct? So I have C4H10 plus O2 give us CO2 plus H2O. So somebody will help me with the balancing? Somebody is ready? So what should I do first? 4 where? Here? Okay, so let me just, okay, 4. I have 4 carbons at the left, 4 carbons at the right. So carbon is balanced. How about the oxygen? I have 10 left. I have 2 here. So I put here what? 5, correct? 5. So hydrogen is balanced. How about oxygen? I have here what? 8, 4 multiplied by 2, 8, and here is 1, 5 multiplied by 1 is 5. So this one is 13. Oxygen is 13, and here is 2. If I have odd and even numbers opposite to each other, then I have to go through what? A fraction. I have to go through what? A fraction. This is the highest one. I'll put this one here, 13. This is 2 here, then I'll put 2 here. If it's 3, I'll put 3. Correct? Everybody following? So then I have to get, the atoms are not fractional. There's no fraction atom. Fraction of atom is not present. So then I have to have this one here. So 13 over 2, I have to get rid of the 2 here, multiply the whole equation by 2. So then I have here 2 C4 H10. 2 multiplied by 13 over 2, 13. Correct? 2 multiplied by 4, 8 CO2. 2 multiplied by 5, 10. Okay, guys. Now let's count this. The carbon, how many we have? 2 multiplied by 4, 8. Oops, sorry. How many we have here? 8. 2 multiplied by 4, 8. Here, 8 multiplied by 1 is 8. So carbon is good. Carbon is good. How about hydrogen? 2 multiplied by 10, those are 20. 10 multiplied by 2, 20. So 20. Then here we have 20. So hydrogen is good. Hydrogen is good. Now the oxygen. Oxygen is challenging. 8 multiplied by 2, 16 oxygen, plus 10 multiplied by 1, understood not written, is 10. So this is 26. Correct, guys? 26. How about here? How much? 26. So everything is balanced. So what coefficient we have? Somebody will tell me what coefficient we have. Okay, I hear that. So I heard 2 to what? 13 to 8 to what? 10. Okay, guys? Those type of questions, they might appear as well. They might appear inside the final exam. Okay, guys. Okay, now we'll go type of chemical reaction. So, type of chemical reaction. Can I take this one out? Everybody has it? Everybody has it? Okay, so type of chemical reaction. Well, the type of chemical reaction, you can tell me if you have, how many types of we have studied in the lab and in the lecture so far? How many? 3? More than 3. 8? No, less than 8. We have more than, but we studied only 5, correct? 5. We studied single, and then double, the opposite, double, single replacement or displacement. And we have then double replacement, displacement. And we have combination, and sometimes called synthesis. Okay, we have what? If I can combine, I can what? Decompose, correct? Decomposition. Then number 5. Number 5, guys. Combustion. Reaction with pure oxygen. Reaction with pure oxygen. Okay, guys. So if I will give you a worksheet, and then you can tell me what type of reaction. So okay, so we are there. We are almost there. So here it is. Can I take this one out? If you take it out, and then let's take this one out here, and then let's come here, ask chemical reaction. Chemical reaction types. Worksheet. Okay, we don't need the answer, but okay, guys. So we don't need the answer. We can answer. They bring you answer. We don't need the answer. We need. Yes, that's a good one. That's a good one. So we'll snip it here out. Okay, guys, here it is. What's the first one? What's the first one? Come on, guys, don't let me down. What we call this second one? It's not here. That's just worksheet. I'm looking for the next example. So what is this? The first one. I want to hear. I know it's Monday and everything is tired. What's that? Single? That's catastrophic, guys. Single, you have to keep one is orphan, correct? There's no orphan here. That's compound coming out. So what's the first one is? Come on, guys. Double. How about the second one? What's that? Look at the second one. That might come in the final exam. I don't know. What's that? Magnesium take over the carbonate and lithium take over the chloride. They're swapping what? Partners, correct? That's again what? How about number 3? Number 3. Come on, guys. What's going on? Number 3. Number 3, guys. What's that? What type of reaction is number 3? Well, we have a problem. Houston, we have a problem. A real one. What's that? You are reacting this with pure oxygen. What is this? Anytime I react a matter or compound or anything with pure oxygen, this will be what? Well, then you have to review this one here. How about number 4? Number 4. What's that? Single, guys. Well, we have a problem here. So we have a problem with this. How about number 5? I did not hear anything. Number 5, decomposition, correct? Number 6 is that combination, or the second name of it's called synthesis. Seven is, well, I can't. This is combination, but I can't move it. I have to take them out. So can I take this one out? Okay, so let's do number 7. 7 is single, double. What's the difference between single and double? Single will replace one. The double, they swap their partners. The cation will take the anion from the first one, and the anion from the second. The cation from the second will take the anion of the first one. They swap partners. So this one is double. Come on, guys. How about 8? 8. What's that? Are they swapping partners? No. One of them is kicked orphan, which is this one is orphan here, silver. Yeah, I want to hear it. I want to hear that. So you have a doubt, you keep quiet, correct? Okay, so 9. 9. Come on, guys. We have a problem with this. Double? Come on, guys. Double? No. What is this? Well, I'll say you have really to review this. Really, you need to review this, because it does not look very shiny here. It does not look very good, guys. I'm telling you up front, it's not looking very good with this type of reaction. At least one question or two. So don't lose those questions. So how about number 10? I will stop. Number 10 and 11. So what do we call this? Combination, correct? How about 11? How about that? Single. So oxygen will take over the serine and keep the chlorine orphan. That's single. How about number 12? Number 12. Are they swapping partners? Double. Yeah. Ask yourself those questions. 13. Decomposition. Okay, we are talking now. Now it's clicking. It's like a bulb in the dark, turned on. How about 14? 14. Decomposition, correct. Okay, so I think that's enough, correct? That's enough. So you can look in there's a lot of stuff there out there in the web. So okay, guys. Then we have to determine number of moles and molar mass. Number of moles and molar mass. Okay, guys, I have 2.50 gram of sodium chloride. You have to calculate the moles. So, what's the definition of a mole? I know the mole is an animal, but this one has nothing to do with the animal mole. It has to do with the chemistry mole, correct? So the mole is a ratio, correct? What is this ratio is? Mass over what? Molar mass, correct? It's a ratio. The mass is given to you, 2.50 gram. How about the molar mass of sodium chloride? Well, you go and look at the atomic mass of each element and then say, okay, each element, sodium is 23.0 gram per mole, correct? Chlorine is 35.5 gram per mole. Add them up will be 5, and then 8, 5. And this one here will be 58.5 gram per mole. So the gram with the gram cancels out. Gram cancel out and the mole will come up there. So, how many sig figs we have? Our answer is 3 sig figs. Here is 3 sig figs, correct? And here is 3 sig figs. So our answer is 3 sig figs. Everybody knows how to do the moles? Calculate the mole? Okay, that's good. So, now I need from you to calculate the molar mass of a compound. Can I take this one out? So what is the molar mass of sodium phosphate? I need to ask you the molar mass. Could you calculate for me and tell me what the answer is? Then we can calculate. I'll give you a few seconds. So have 30 seconds, have a minute. So can you calculate it? Tell me how much you can get this one here. So you need the periodic table, correct? You need the periodic table. And you have to look at the atomic masses, not the atomic number, atomic masses. Well, I can write it for you. I hope you get them all. Sodium is 23.0 gram per mole. Phosphorus is 31.0 gram per mole. Oxygen is, that's oxygen. Oxygen is 16.0 gram per mole. Now, how much is the whole thing? Remember, you have to look at the ratio. So, okay, guys. So, it is, guys. So, calculate, tell me what's the answer. This is 3 sodiums, plus, this is 1, correct? 1 understood, not written. 1 phosphorus, and this is multiplied by 4. So how much is it? How much? 164? 164.0 gram per mole. So we have, all those are 333, I think, when you add them, 1 digit after the decimal. So it does not really matter, because we are adding, has nothing to do with the multiplication. So we have 1 digit after the decimal, 1 digit, 1 digit, 1 digit. So we have 1 digit after the decimal. Now, let's see if you have done a good job in that. I put, everybody has it? Everybody has this? Okay, let's check it out and see if you did a very excellent job in this. So we are just checking. Not cheating, we are checking. So sodium 3PO4 molar mass. How much is it? How much? We did 164.0, and they got what? 163.94. They used the real atomic. It's like a ghost here or something. Well, this is a vacuum. It's a vacuum. They are working on the vacuum because all the vacuums are not working here. So this is our answer. Is what is correct? Are you following me here? 163.94 we used just rounding. We did not do the exact. So, like example here, let's go here. Look at the. Let's look at the sodium, like oxygen. Oxygen is not, the atomic mass of oxygen is, we did 16, correct? That's not really exact. It's 15.999 gram per mole, and so on. Sodium is not. We used what? We used 23 gram per mole. That's not true. Okay. Phosphorus, we used what? 31.0 gram per mole. What we used just whole rounding. But if you use really what's inside the periodic table, will be off, because you see the oxygen here is off a little bit. And the same thing with sodium. Sodium will be off. Phosphorus will be a little bit off. So that's what came to 163. So, but the answer correct. So now we are coming to the, okay, so the pH. The pH we said is, it's not really correct pH. It has to be pH3O plus, correct? And this is minus log the concentration of H3O plus. Now, I give you the solution, and then you have to determine the pH. Or they will give you the pH and you determine the acidity, basicity of this, acidic, neutral, or basic. So let's look at the solution that has the pH of 6.8, correct? What it will be, acidic, neutral, basic. What is this? The pH 6.8, and you have to determine whether it's acidic, whether it's neutral, whether it's basic. Which one? Acidic? Any other? Any other? 6.8 acidic or basic or what? You have 6.8. That's almost what? 7. We have to put it 6.5. If it's 6.4, this is acidic, yes. 6.5, because always the 5 is rounded as 1. That will be what? Yes. That will be what? That's the problem. Well, the students are learning from 0 to 6. From 7, this is acidic, correct? This is neutral. And then from 8 to 14, that's basic. That's what you learned, correct? But that's not true. How about if you have in between? In between those ranges, what you can tell them? You can't. See, you have, I told you to look at the in between colors and then estimate that color. So if it's always less than 5, that will be acidic. If it's above 5, that will be then neutral, close to neutral or neutral, correct? So now I will give you the pH, and I will tell you to determine the OH minus concentration and the hydronium ion concentration. So the pH is 3.5. Correct, guys? The question here, you have to calculate for me the hydronium ion concentration and the OH minus concentration. So, how we do that? Give you 1 minute this time. 1 minute. This will be a couple of questions will come on that. Couple of questions on that. So calculate for me the hydronium and the hydroxide with the pH of 3.50. So I'm looking for the next one. Okay, guys, we are almost there. We're almost there. 4 more questions or 5 more questions or so. We'll be there. So, you know how to calculate this. This will come in the final exam of the lecture, the final exam of the lab. So you have a pH value, and then you have to determine the hydronium ion and the OH minus. Somebody will tell me how to do it? Come on, guys. Tell me what's the answer. So, if I have, this is the H, correct? Which is H3O plus. I need to get what? The concentration of H with this one here. Remember, this one here is minus log hydronium ion equal 3.50, correct? Then the hydronium ion concentration, which is here, equal 10. The anti-function of log is 10. And then the minus here will come in the top. And then whatever the value here, the pH value, correct? Minus the pH, which will be 10 minus 3.5. Okay, guys? 10 power minus 3. The minus came from the definition of the pH. Okay, guys? How we get this one here? How we get number here? Okay, guys? How? Well, we have a relationship between Kw, H hydronium ion, and OH minus. So, Kw will be hydronium ion multiplied by OH minus. Correct? Kw is 1.00, 10 minus 14. Hydronium ion is this one here. This is the hydronium ion. Correct? This is 10 minus 3.5 multiplied by the OH minus. So, divide both sides by 10 minus 3.5. 10 minus 3.5. This cancels out. The OH will be, OH minus is 1.0010 minus 14 divided by 10 minus 3.5. Okay, guys? Everybody knows how to do it? Everybody knows how to do it? Correct? Hope so? No? No? Okay, so then we have to see the correct balancing chemical equation. We did balance those, I think. We covered the balancing chemical equation. Correct? Now we'll do titration. Any question about this? Any question about this? We'll do titration. Okay, guys. So, can I take this one out? You have it? Okay, so here, guys. So remember the purette here with the titration. We did titration, and this is my flask here. Correct? That's the purette from 0.00 ml to 50 ml, and we had sodium hydroxide here. It has a concentration of 0.98 0.50 molar. And then that's the burette. And then you did all titration with vinegar. You took about, say, 10 ml of vinegar, 3 drops of the indicator phenolphthalein, and you guys just to see, it has nothing to do with the reaction, but to see the endpoint much better than you added 10 mL of distilled H2O. And the question is, you have to determine mass over the volume for the vinegar and the molarity. Of vinegar. Okay, guys? So, how we can approach this? Well, we have to state that after the endpoint, sodium hydroxide stopped. It consumed about, say, here it is, so say about 30.0 ml. So it took 30 mL to reach the endpoint, correct? So, how we do this? That will come in the final and maybe in the lecture as well. So, can I do it here for you guys? First, convert this one here into what? That's the consumed sodium hydroxide to reach the endpoint, from colorless to pink, correct? So, convert it into liters. So this is 0.0300 liter of sodium hydroxide. Then you multiply it, or just make a line here. That's liter, 0.0300 liter of sodium hydroxide. This is sodium hydroxide. Multiplied by the concentration of sodium hydroxide, correct? Which is 0.9850 mole per liter. This is again sodium hydroxide. Now, let's follow the liter with the liter cancels out. Now we have what? We have moles of what? Of sodium hydroxide. And the reaction is 1-to-1 mole ratio. Remember, this is vinegar here, plus sodium hydroxide will give you salt, sodium acetate, plus H2O. And we are interested, this is to know this is 1 mole of this to 1 mole of this, 1-to-1 mole ratio. So I have here 1 mole of vinegar will stand 1 mole of what? Of sodium hydroxide. So mole sodium hydroxide with the mole sodium hydroxide cancels out. Okay, now transfer the whole thing to mole of vinegar, correct? Now, if I want to see what the this is a mole of sodium, this is mole of what? Of vinegar. Mass over the volume will be, I need the mass of vinegar. So I need to know the molar mass of vinegar, correct? The molar mass of vinegar, CH3COOH. This is 12. This is 3 multiplied by 1. This is 12. This is 16. This is 16. This is 1. If you add them up, it will be what? Add them up and see what will happen. 60.0 gram per mole. Okay, so this is 60 gram. That's vinegar here. Per mole vinegar. So vinegar moles cancels out. So I have the grams here. I put the mass here. Okay, I have the mass for this following. The mass is here by multiplying by the molar mass divided by the 10 mils. I use 10 mils of vinegar. So how much is the mass? Somebody had calculated 0.0300 multiplied by 0.9850 multiplied by 60. How much is it? How much is it? Nobody calculated? Nobody? 0.03 multiplied by 0.985 multiplied by 60. That's the molar mass multiplied by the molar mass. How much is it? How much? Come on, guys. No, not dividing. Multiply. Those three are multiplied together. Three values are multiplied together. How much? 1.773. We have all those are 3 digits, correct? Three suffix. So 3 suffix will be 1.77, correct? 3. Now this is mass. This is the mass, correct? That's what we got, mass. The volume here, 10.0 ml, and this is gram. And then you multiply this here by 100%. So how much? This is the mass divided by 10 multiplied by 100. So it will be 17.7%. Correct? You can calculate it. 17.7%. Correct, guys? That's mass over the volume. Now, how about the molarity? Well, the molarity here, we have not to go nowhere. We have to stop here. This is this 1.77, correct? This is the moles, correct? That's the moles of vinegar. Then you divide the moles, which is 1.77 mole, by liter. The 10 mils converted into liters, 0.0100 liter. 10 milliliters is 0.01. That's mole per liter. What's the value here? What's the value will be? 0.177, is it? The answer is, I think, is 0.177. So that's the molarity, guys. That's what? The molarity, and this is the mass over the volume percentage. So the last 4 I have for you. So I did the mass over percentage. So one more thing here, we have to look at the buffer. Okay, guys, at the buffer. So I'll take this one out. Take this one out. Okay, so that's calculation of the titration calculation. Now I need to get, here is the, just hold on, guys, buffer. Okay, buffers. Let's look at the buffer. Here it is, guys. Those are calculations, correct? I need something you have to determine, not a calculation. Determine for me if you can. No, not the calculation. That's Yes, let's look at this, guys. Here, guys, let's look at this. Number two. Let's look at number two. Which of the following mixture is an example of a buffer solution? Those type of question will be in the might be in the lecture and might be in the lab as well. So which one of A, B, C, D? They give you the answer, but which one? Which one? Don't tell me, play on me smart here. You have the answer here, but which one? I did not want the answer. Which one? This one is not, because a buffer is made of a weak acid with its conjugated base, or weak base with its conjugate acid. So a buffer is made of two possibilities: weak acid plus its conjugate base, or weak base plus its conjugate acid. So this one's strong. This is strong acid, which is HCl. That's not a buffer, correct? This one is weak acid, and this is its conjugate base. That's yes. This one here, strong acid. This one here, strong base. So strong base, strong acid will not make. Those are not. The only thing is weak. This one is weak. This one only correct. Okay, guys. How about Q3? Which of the following mixture is not an example of acidic buffer? Which one? This is a buffer, correct? That's weak acid. Weak. This is weak. This is weak. The only thing, this is strong. This is strong. So this is not a buffer. Not a buffer. Okay, guys. So okay, mass percentage will come. Okay, guys. Can I take this one out? Take it out. Now let's look at the I want to see what's the mass. Sorry here. Mass over mass percentage. I have sodium chloride mixed with sugar. So sodium chloride is 25.0 grams, and this one here is 75.0 grams. What is mass over mass percentage for this mixture? Can you tell me? Which one first you have to determine which one is solute? This is small amount. This is solute, correct? This one is larger amount. This is solvent, correct? Mass over mass of the solution, so will be mass over mass percentage will be the solute, mass of the solute 25.0 gram, and then mass of the solution is mass of the solute plus mass of the solvent, and the whole thing multiplied by 100%. So it will be 25 This is 100, correct? So multiply by 100. So this is, how much is it? 25.0%. Okay, guys? So that's mass over mass. How about if I just squeeze it and then do mass over the volume? We'll do mass over the volume. Can I take this one out? Okay. Just bear with me. I know you are eager to leave, but just bear with me a little bit. Mass over the volume percentage. So sodium chloride is 25.50 gram. The volume of the solution is 100 gram H2O. ml, sorry. So mass over volume, mass of the solute is 25 gram, and the solvent is 100 ml, and the whole thing multiplied by 100%. ml, gram per ml, yeah, gram per ml. The unit's here. So multiply 100 with 100 out. This is 25.0 gram per ml percentage. Okay, guys. So okay, chemical equilibrium. Chemical what? Equilibrium. Okay, guys. Chemical equilibrium. Okay, guys. Chemical equilibrium, and the last one. Okay, and then one stoichiometry. Can I take this one up? Two more. So two more. We have to look. Okay, guys. So the first one here, we have Le Chatelet principle worksheet without answers. Here, guys. Okay, guys. So here it is. I hope there is no answer to that. Yes. Let's take the second one. Maybe another one. Let me take another one. Right? Let's see if we can get another one. Okay, guys. Here it is. Not calculate. Okay, guys. So you have a reaction here, guys. You have a reaction here, correct? And we want to see we'll not do any calculation. Just we'll look at the quantitative of Le Chatelet principle, qualitative approach. So you have a chemical reaction here, correct? So this is your chemical equation, okay? That's equilibrium, double arrow here. That's chemical equilibrium. So I'm asking you what will happen if you add hydrogen to this reaction? Where will be the shift? To the left or to the right? Which way? You added hydrogen to this reaction. to the what? To the right. Because hydrogen will add itself here, the whole thing will shift the other side. If you add methanol, if you add this one here, methanol, where will be the shift? You add it to the left side, will be the shift to the left. If you remove CO, you remove this one here, take it out. So this arm will be less stressed because you have taken CO out. So this one will be stressed, so will be where? To the left. If catalyst is added, no change. Catalyst has nothing to do with the equilibrium. It does have to do with the rate, increasing the rate of the reaction. Now, how about it's exothermic or endothermic reaction is this? If the sign is negative, this is exothermic. If it's positive, then it's endothermic. How about E? Okay, heating the reaction will be the shift. Exothermic is always the heat at the left, so it's SO CH3 C, not the left, the right, sorry, plus heat. Exothermic will be at the right, that's released out reaction. So heating the reaction, where will be the shift? Left or right? I'm heating, I'm adding more heat. Where will be the shift? To the left or the right? Left or right? The heat will add itself to here, correct? So this arm will be more stressed to the left. Then if I have cooling the reaction, what will happen? I have to cool means I'm removing the heat from here. So this is missing something. So this has to react to give back something for the heat. So will be the shift which way? Will be to the right. Okay, guys? And okay, last one, and then I'll let you go. Last one, and then I will let you go. So last one, and I will let you go. So we covered mostly all the stuff here. So now we have I have calcium plus oxygen give us calcium oxide. 2, correct? And 2. Now, this one is excess. Give you all this. This one excess. This one is limiting. Small amount. So, if you use excess of oxygen, 80.0 gram. Question is how much of how much is your calcium oxide? How much is what is your calcium oxide? This one here. Calcium, how much is it? So this is type of stoichiometry will come in the lecture as well in the lab. So here it is. You start with 80 grams of oxygen, which is an excess. So 80 grams oxygen, correct? I need to get rid of the grams of what? Of oxygen. What's the molar mass of oxygen? O2. 2 multiplied by 16. This is 16.0. That's 32.0 gram of oxygen per mole of oxygen. That's divided by the molar mass. Grams with the grams cancels out of oxygen. Correct? Then I have 2 moles of calcium oxide to 2 mole to 1 mole. This is 1 here. This is 2 to 1 mole of oxygen. Mole oxygen cancels out. Okay, guys. Then I need the grams of calcium oxide. Well, I need to get the ratio. The molar mass. Oxygen is 16, guys, and this one is 40 gram per mole. It's gram per mole. So this one here, mole. This one here will be 0, 6, and 5. So 6.0 gram of calcium oxide per mole of calcium oxide. Mole with the mole cancels out. So now you have to multiply 80 by 2 by 56.0, divide the whole thing by 32. Somebody has it? Somebody has it? No? But anyway, that's the setup here. You can do it at home, but you have to start with whatever is given to you. Divided by the molar mass, whatever is given to you to get the moles. Get the mole ratio from between the product and the reactant from your original equation here. This is the original equation here. And then multiply it by the molar mass of your designated product you are looking for, and you can calculate the whole thing. Okay, guys, I'm stopping here. Tell you good luck. I will see you next Monday for the final exam in the lab.